Ever wonder what really happens with your computer's memory when you click on something? It's easy to picture it as just one big storage bin, right? But the reality is way cooler. It's actually this incredibly clever, multi layered system. Today, we're going to pull back the curtain on one of the most elegant ideas in all of computer engineering, the memory hierarchy.
Now, to really get why the memory hierarchy is so brilliant, we first have to understand the problem it's trying to solve. I mean, every single computer designer on the planet has to wrestle with this core challenge. It's a classic engineering trade-off, really.
And that brings us to the big question. Why can't we just have it all? Why can't we build a computer with one single type of memory that is absolutely huge, ridiculously cheap, and super duper fast? I mean, that sounds perfect, right? Well, the answer, as it often does, comes down to the cold, hard reality of physics and economics.
So you're basically stuck between two options. On one hand, you've got this blazing fast memory. It's incredible, but it's also super expensive, which means you can't afford very much of it. On the other hand, you've got memory that's dirt cheap and you can get tons of it, but it is painfully, painfully slow. So you see the dilemma? Speed, cost, and size. You can't have the best of all three. That's the fundamental trade-off. So what do engineers do when they're stuck between a rock and a hard place like this? Well, they don't pick one. They get clever. They build an elegant compromise. They design a whole system that tries, and succeeds really, at giving us the best of both worlds. And that solution, that's what we call the memory hierarchy. Okay, so what is it officially? The memory hierarchy is basically this organized arrangement of different kinds of memory in a computer. The keywords there are organized and layered. This isn't just a random pile of chips. It's a very deliberate structure. And its entire purpose is to strike a perfect balance between those three things we just talked about: speed, capacity, and cost. Now, the best way to get your head around this whole thing is to think of it like a pyramid. Seriously, picture a big pyramid, and right at the tippy top, at the peak, sits the CPU, the computer's brain. And that CPU is hungry for data. It wants information, and it wants it now. The entire rest of the pyramid is built just to feed that need. And this pyramid has three simple rules. That's it. As you go down the pyramid, away from that speedy CPU at the top, a few things happen. First, things get slower. Second, they get a lot cheaper for the amount of space you get. And third, the amount of space, the capacity, gets way, way bigger. All right, you ready? Let's take a tour of this pyramid. We're going to start right at the top, at that lightning-fast peak, and work our way all the way down to the huge, slower base. Okay, level 0, the absolute pinnacle. This is as high as you can go. We're talking about registers. This is, without a doubt, the fastest, most VIP memory in the whole computer. So why are they so fast? It's all about location, location, location. Registers are literally built inside the CPU. The data doesn't have to travel anywhere. It's already there. The catch? They're minuscule. We're talking tiny. A register might only be big enough to hold a single number that the CPU needs for the calculation it's doing right this second. Okay, moving one step down the pyramid, we find cache memory. A great way to think about the cache is as the CPU's personal super fast assistant. The cache is still right there on or next to the CPU, so it's also extremely fast. Not quite as fast as registers, but pretty darn close. And its job is absolutely critical. It's like a little staging area. It holds data and instructions that the computer is pretty sure the CPU is going to ask for next. This is a huge deal because it stops the incredibly fast CPU from sitting around twiddling its thumbs, waiting for slower parts of the system to catch up. All right, let's take another step down. This brings us to a level you've probably heard of: RAM, Random Access Memory. If the CPU is the brain, you can think of RAM as the computer's main workbench. Whenever you launch an app, your web browser, a game, whatever, it gets pulled from your hard drive and loaded into RAM. This is where all your currently running programs live. We're talking gigabytes of space here, so it's much, much bigger than the cache. But it's also noticeably slower. And finally, we've reached the bottom. We're at the massive, wide base of our pyramid. This is secondary storage. You know this as your hard drive or your SSD. This is the computer's long-term memory, like its filing cabinet. It's where everything is kept permanently. All your photos, your documents, your operating system, all of it. The capacity is enormous, right? We're talking terabytes these days. But to a CPU that operates in nanoseconds, getting data from here is like waiting for a letter to arrive by snail mail. It's just incredibly slow. And just look at this to see the difference in scale. It's kind of nuts. The cache is measured in megabytes. It's that tiny little sliver. Then you've got RAM in gigabytes, but your storage? That's in terabytes. A terabyte is 1,000 gigabytes. So the jump in sheer size from one level to the next is just staggering.
So, after all that, you might be asking, why? Why build this complicated pyramid with all these different layers? What's the point? Well, the ultimate goal is to create a kind of magic trick, a beautiful and really effective illusion.
And this is the big takeaway. The whole point of the hierarchy is to give the CPU the illusion that it has access to a practically unlimited amount of super fast memory. That's the trick. The whole system, registers, cache, RAM, storage, they all work together to pull off this one amazing feat. See, behind the scenes, your computer is constantly and really smartly shuffling data up and down this pyramid. It's always trying to guess what the CPU is going to need next, and it yanks that data up from the slow, big storage into the fast, small memory just before it's needed. That nonstop, frantic shuffling is what makes your computer feel so snappy and responsive.
You know, this elegant pyramid design has been the bedrock of computer architecture for decades. But now, with all these new memory technologies coming out, ones that kind of blur the lines between these neat layers, it leaves us with a really fascinating question to think about. Will this pyramid be around forever, or is there something totally new on the horizon that could one day replace